Hello everyone, welcome to the class real-time systems. Today we are going to see model 4. Model 4 is nothing but an operating system. So in this operating system we are going to talk about introduction, real-time multitasking operating system, scheduling strategies, priority structure, task management, scheduler and real-time clock interrupt handler and memory management, code sharing and resource control, task operations and communication, mutual exclusion. So these are the topics which we are going to study in this module. So today first we'll talk about introduction and the real-time multitasking operating systems. So when I come to the introduction, we know that the operating system, which is nothing but it lies in between the software and hardware. Okay, so that software design is simplified. If the details of the lower level of implementations on that specific computer using a particular language that can be hidden from the designer. Actually, the operating system for a given computer which converts the hardware of the system into the virtual machine with the characteristics defined by the operating system. So that operating systems were developed to assist the operator in running a batch processing computer. So then developed to support both the real-time systems and all the multi-access online systems. So actually a traditional approach is to incorporate all the requirements inside a general purpose operating system as shown below. I'll show you the general structures of the operating system. To access the hardware of the systems and to the input output devices is through the operating system. So because we know that it is lies in between the hardware and software. So this is the general structures of operating system which provide all the facilities that are not required in particular application and add to the overhead. So here if you can see here in this diagram, there is a two division in between the operating systems. One is this is the hardware and also a software. So in hardware if you can see here it is CPU and then input output devices are there. CPU and the input output devices are there. In the software there are multiple divisions are there. On the top layer it is nothing but an application program, and the next is language support. For that application the languages which supports that, and the utilities, what are the utilities are given that. So in that it is nothing but an operating system. So everything is nothing but operating system. Okay, the input output subsystems, the file manager, the file which is used to store, read and data. So everything which is controlled by this file manager. And scheduler is nothing but selecting the next process for execution, that is nothing but a scheduler. And the dispatcher and interrupt handler. So dispatcher, the selected program will be given under the CPU execution, and interrupt handler, if any other interrupts are raised, so that will be handled by this interrupt handler. Okay, so this is the typical general purpose operating systems. So everything whatever which is blocked here, that is nothing but an operating system. So the operating system will manage language support, utilities, and then input output subsystem, file manager, scheduler, dispatcher, and also the interrupt handler. So these are the things which is supported by the operating system. And the minimal operating system. So the minimal operating system is nothing but the diagram which shows the minimal operating system. Actually the recent operating system which provides only the minimum kernel or the nuclear have become popular. The additional features can be added by the application program writing in a high level programming languages. So here there is a differentiation between the operating system and the application software that becomes blurred. Okay, so this approach has too many advantages for the application that involves the small embedded system. So if you can see in this diagram, there is a differentiation between the hardware and software. So in hardware there will be a CPU and also input output devices. In software you can see everything is nothing but an application software. So there is no differentiation between the application software and also the operating system and also application software. And kernel nuclear systems are there. Okay, so the kernel is nothing but the heart of the operating system. So the everything will be controlled by this kernel, or kernel is the heart of the operating system. Okay, and so this is the relationship between the user and also a computer system. So there is a relationship between the various sections of a simple operating system, a computer hardware and user, which is shown in the figure. So if you can see here the user which is connected to the command processor, and then application software, again this command processor application software connected to the BDOS and BIOS, and that is connected to the CPU, disk and input output driver, hardware and software. Okay, So the whatever the user command that will be sent to the user processor, that user processor which provides a mean by which the user can communicate with the operating system from the computer console. Okay, and the actual processing of the command which is issued by the user, which is done by the BDOS. So the whatever the user commands are there, so actual commands are processed by this BDOS. BDOS is nothing but a basic disk operating system which also handles the input, output and file operations on the disk. Okay, and so the application program will communicate with the hardware of the system through the system call which are processed by BDOS. Okay, and the next is which is connected to the hardware, the BIOS, which is connected to the hardware, CPU, disk and input output processor. Okay, so that BIOS, basic input output system, which contains the various disk drivers which are manipulated, and the physical devices may vary from the implementation to the implementation as it has to interact directly with the hardware of the computer system. So that devices are treated as logical or physical unit. So what is a logical device or a software construct used to simplify the user interfaces, user program which performs the input and output to the logical device, and then BDOS connect the logical devices to the physical device. Okay, so that actual operations of the physical device is performed by the software in BIOS. So access to the operating system function is by means of subroutine call. The informed actually the information is passed onto the CPU register of the machine. So the function cannot be called directly from the most of the high-level programming language, which provides the isolation between the operating system and the programmer using the high-level languages. So this is the example of information hiding. So that operating system acts as a virtual machine through the runtime support machine. And the real-time multitasking operating system. So far whatever we have discussed, it is nothing but an introduction about the operating system, how the operating system, there is a differentiation between the operating system and also a blurred operating system. So in blurred operating system there is no differentiation between the application program and also a operating system, but in the typical structures of operating system we'll be having a differentiation between each and everything. What are the facilities, what are the operations which is performed by operating system, including from the utilities, from the file driver and scheduling, dispatching, interrupt handling, program support, input output subsystem. So everything which is handled by the operating system. So this is what we have discussed in the previous topic, and also we have discussed about the user, from the relationship between the user to the devices. So from the user to the device there is a command will be generated from the user that will send to the command processor. So actual the command will be processed by the BDOS, and from this BDOS the command will be sent to the BIOS. The BIOS, the basic input output system, will handle all the input output devices. So that is what we have discussed in the these previous topic. Now this real-time multitasking operating system, here we are going to discuss about what is a multitasking operating system. Okay, so in recent year the division between the operating system is designed for real-time applications and other has been blurred. Okay, example, the modular 2, it's a multitasking real-time application that runs on the top of the single user. Okay, Unix, and then OS bar 2 that supports the multi-user and multitasking application. So now we are going to talk about the multi-user and multitasking operating system. So what is a multi-user and what is a multitasking, and what is the difference between multi-user and multitasking operating system we are going to talk about. So first of all, the multi-user, it's nothing but it ensures that each user can run on a single program as if they are running an entire computer system for themselves. Okay, so that operating system ensures that one user program cannot interface with the operations with the other program. Can interface with the other program. Each one is predicted environment. The primary concern is to prevent the actual OS, which ensures that the one user program cannot interfere with the operations of the other user program. Each one runs in the protected environment. So the primary concern is to prevent the one program either deliberately or through the user corrupting others. And the diagram which shows the multi-user operating system and multitasking operating system. So the multi-user operating system, if you can see here, the each and every user which executes their own program. Okay, so for that there is a separate data space is allocated for the each and every program. The data will be stored into that separate memory area. Each user which executes their own program, and the data will be stored into the data. Okay, data will be stored into the separate area. So the each program which executes their own data, and that will be stored into the separate area. So the diagram which represents, there is a multi-user which executes the separate program and also a separate data. So there is no common area here, so the data will not be combined with one user to the another user. In the protected environment, the data will be executed here. So that is called multi-user operating system. And multitasking operating system, if you can see here, there is a user. So in that user, there is a one program user wants to execute. That program is divided into the number of tasks. So in the diagram, you can see here the number of tasks are task 1 to the task n. The n number of tasks will be there. So the each task which executes their own data, and then the data one can be used by the other task also. So here there will be a inter-task communication between the task. Okay, so the common area, the data will be stored into the common area. So in that, the data will be accessed by the other task. So there is a inter-task communications which is present in this multitasking operating system. Okay, and multitasking operating system, it is assumed there is a single user and then various task operators to serve the requirements of the user. The combination which requires that the task communications with each other and shares the common data. Okay, in the good multitasking operating system, these operations are regulated so that the OS is able to prevent the unplanned communication or data access, and hence the protect data which is private to the task. Okay, so there is a fundamental requirements of the operating system is to allocate the resources to the computer to various activities which have to be performed. Some activities are critical, hence requires more priority than the others. So that should be a means of allocating the priorities to each and every task, allocating to the CPU time to high priority task. Okay, so here a real-time operating system, multitasking operating system has to support the source sharing and the time requirements of the task, and then functions can be divided as follows. What are the functions will be? The task management, memory management, resource control, and then inter-task communication and synchronization. So the task management is nothing but the allocations of the memory and processor time to the task. Okay, it is nothing but the scheduling. And memory management is nothing but the controlling of the memory allocations. And resource control, it is nothing but the control of shared resource other than the memory and the CPU times. And intertask communication and synchronization, which nothing but the provisions of support the mechanism to provide the safe communication between the task and to enable the task to synchronize their activity. Okay, support for the disk file and basic input output device drivers and utility programs are the other features. So this is nothing but the typical structures of real-time operating system. So here you can see here the task management which is used to control the resource allocation and management, command processor, input output system, and file manager, and the task system task, and then application task which is command at the user level and based on the real-time task and service routine. So the overall control of the system is to provide by the task management model, which is responsible for allocating the use of the CPU. So it is also referred to as monitor to execute the control program. So system tasks are shown in the user level. Some operations are performed by the operating system, and the utility programs run in the memory space that is allocated to the user or the application program. Okay, these are the references of real-time systems. I hope this topic is very helpful for you. We'll meet you in the next class. Thank you all.